So I promised you one of the special cases when you're finding the interval of convergence, we have a game plan. The game plan. First, we're going to use the ratio or root test and set it less than 1, because that's where the convergence is going to take place. Then you test the endpoints, and then you write your answer in interval convergence. So we're going to use the ratio or the root test. Y'all told me you wanted to use the ratio test, so we go ratio. When we're doing the ratio test, we look at the next term, the k plus 1 term, and that's it right there. Everywhere I saw a k, I put a k plus 1, and I'm going to multiply it by the reciprocal of that fraction there. So that's multiplied by 2k plus 1 factorial divided by a k to the 20th and an x to the k, and that all needs to be smaller than 1. Now what? I distribute in there because I'm cleaning this up. That's how I got the 2k plus 2, and then I add that 1 and that 2, and I get a 3. Now we are going to simplify that expression because it looks so complicated. What am I going to tackle first? The x's. Wow. So I had an x to the k plus 1 in the numerator and an x to the k in the denominator, and then they reduce down to an x to the 1. Then what? I'm going to take care of those factorials. Ah, yes. So I multiply by, whoa, okay. It looks like I'm just going to finish simplifying this. All right. That's how it goes. Make it pretty. The absolute value of a product is the product of the absolute values, and I write it as such so that I can see what my limit as k goes to infinity goes. We see that goes to 0 because our denominator has 2 degrees larger than our numerator, and the big denominator goes to 0. So what do I have? I have 0 times the absolute value of x, and we want to know where that's less than 1. But 0 times the absolute value of something is a big fat 0, and we put some extra weight on it. Because now we wait on it because we don't have to do the endpoints anymore. Why? Because that's always true. And when it's always true, that's how we write always, because that's going to converge for all x's.